Okay, we're going to look at some homework solutions for lesson number 3, so we will get right into it. Okay, first question, it asks you to find the length of the hypotenuse to the nearest tenth of a unit. It gave you 15, gave you 25, and then we have x here. So we use our formula, c squared equals a squared plus b squared. What we want to do, we want to make sure we label everything. So our c squared here is going to be our x squared. Doesn't matter what a squared and b squared are. So we have 15 squared plus b squared, which is 25 squared. And then you want to do that math right in your calculator. So give me a sec, I'll get that done for you. 15 to the power 2 plus 25 to the power of 2. And that will give you x squared equals 850. So now what we want to do is we want to square root both sides, square root that. Put that in your calculator, and that will give you a value of x, which equals about 29.15. Okay? It does say nearest tenth of a unit, so I'm going to erase that and make that 29.2 because I had to round up. Okay? So then we'll look at C. C, very similar. So we have 12, we have 4, and we have x. So we have c squared equals a squared plus b squared. Always want to make sure you write your formula. X squared equals 12 squared plus 4 squared. So we'll do that right in our calculator. X squared equals 144 plus 16, which is 160. And then from there, we want to take the square root again. So we're going to take the square root of this side, take the square root of that side, and we get x equals 12.65, which really rounds up to about 12.7, so somewhere in that range there. Okay, next we'll move on to number 3a. Number 3a. So 3a says we have a triangle that looks like this with 25, 15, and we have x. Perfect. And then we want to figure out, okay, what's the length of the indicated side? So again, we'll use our formula. C squared equals a squared plus b squared. Now our c squared here is going to be 25 squared equals a squared, which is 15 squared, plus b squared, which is now going to be our x squared. So I would recommend just throwing these right in your calculator as soon as you get them. So 25 squared is going to be 625. 15 squared is going to be 225 plus x squared, which we do not yet know. So we will swing everything over and we'll get that 225. We get 625 minus 225 equals x squared. So that's going to give us 400 equals x squared from there. Square root this side, square root that side, and you'll get 20 equals x. Perfect. Next thing we'll do, we'll move on to 3c. And 3c, we're going to do the exact same thing. We have a triangle that looks now like this, 13, 12, and the missing side is p. So here's our right angle. So we have c squared equals a squared plus b squared. C squared is 13 squared equals 12 squared plus p squared. So we'll do the math. 169 equals 144 plus p squared. Bring that over just like we did in our other examples. 169 minus 144 equals p squared. That gives me 25 equals p squared. Take the square root of both sides, square root of that. We get 5 equals p. Perfect. And now I think we have numbers 4a and c. Let's make sure. Yep, 4a and c. So 4a, it says find the length of the x to the nearest tenth of a meter. Compare your answers with those of a classmate. Well, we obviously can't do that, but you can compare it to me, which is even better. So here's what I did. 4, 2.2, x. So we want to figure out what's x. C squared equals a squared plus b squared. C squared, which I should actually erase and put x squared because that's what c is. It's our hypotenuse, equals 4 squared plus 2.2 squared. And when I do that math, let's just do that math. 16 plus 2.2 squared gives me 20.84. It's not good enough. We need to square root both sides. So x is going to be 20.84 square rooted, and that gives me 4.56. Perfect. And then as we go, we'll go on to 4c. 4c, same kind of idea, just a different set of numbers. X, 5.2 down here, here's our right angle, 8.3, so we can set this up. C squared equals a squared plus b squared. C squared is x, we have x squared equals 5.2 squared plus 8.3 squared, and then we can just do some math right on our calculator to make it nice and easy for us. So we have 8.3 squared, that gives me a value of 95.93, square root this side, square root that side, and we have 95.93 square rooted. That will give me about 9.8 is what I got for that. Okay, good. Now I think we are on number 5 and number 6. So let's take a look at number 5 here. So number 5, we say we're walking home from school by walking around 2 sides of a rectangular park. So before I even do anything, let's make sure I understand what I'm doing here. Let's draw a rectangular park. That looks like a nice rectangle. Length of the park is 125, okay. Width of the park is 121, okay. So if we were to instead walk diagonally across this park, so now maybe I'm going to walk like this, how far would I have to walk? Okay, well, that's not a big deal. We can figure that out nice and easy. So if this is a rectangle, we know that this side is also going to be 121. So here is our triangle. This is what we were trying to figure out. So using our formula, c squared equals a squared plus b squared. Let's fill in our values. We have x squared equals 125 squared plus 121 squared. And then we can just do that math right away. So we'll do 125 squared plus 121 squared. And that gives me an awfully big number. X squared equals 30,266. I want to make sure we square root that because that would be a very, very far walk if we left it. And we get x equals 173.97. A whole lot more reasonable. And that will take us to the end of part A. So let's take a look at part B. Part B, we're going to go through some triangles, and this should be very, very quick. So let's take a look at that. So we're on part B here. So first we're going to do number 1A. So we have M, N, and O. So what we want to do is we want to label the hypotenuse, opposite, and adjacent. Here is our angle of interest. So our hypotenuse is, of course, going to be opposite our right angle there. Our opposite side is going to be farthest away from our angle of interest. So here's going to be our opposite, and our adjacent is touching it. So that's how you should have labeled that. Okay. As we move on to our next one, let me just draw it out for you here. This is C. We have S, U, T. Good, and now we want to do the exact same thing, labeling everything. Here's our angle of interest right there. So here's going to be our hypotenuse, here will be our opposite, here will be our adjacent. And we have E. So E is a little all over the place, but that's okay. So we have A, B, C. And here is our angle of interest. So if we went to go label these things, here would be my hypotenuse, here would be my opposite, and here would be my adjacent. Always making sure our adjacent is indeed touching that right angle. Good, that's one complete. Let's go ahead and just do a couple more of those with 2. So we'll look at 2A. 2A has this involved for us. Something like that. Just while I'm drawing, I'm just going to draw C here because that's going to be up next for us as well. So we have something like that. Okay, perfect. Let's go ahead and mark these things. Very first thing we should do is mark our hypotenuse, which is easy. We can do it on both of these right away. You don't even have to think. It's always opposite our right angle. Next, we'll label our opposites. Those are opposite our angle of interest. And then we have our adjacent, which is touching our angle. Excellent. Okay, now we have 3. So what we want to do here is this is going to give us a nice little chance to take a look at what we're going to be doing tomorrow when we're really going to need those calculators. So let's take a look at 3. 3, we have a triangle like this. I'll just make sure that we're on it. And we have 10.4, we have 8.6, and we have 5.8. So here's our triangle. What we want to do is we want to mark the opposite as the length of the hypotenuse. So we want to take the ratio of our opposite, so what we're looking for is we're going to look for opposite as a ratio, means divided by, our hypotenuse. So we want to figure out, okay, well, what's our opposite? What's our hypotenuse? Well, this might be a complicated problem unless we start with labeling like we always should. Here is our hypotenuse, here is our opposite, and here is our adjacent. So what we're going to do now is we're just going to fill in our values. Our opposite is 5.8. Our hypotenuse is 10.4, just by taking a look at what we have already marked down. Next thing we want to do is we want to reduce that. So we'll take our 5.8, divide it by 10.4, and then we want to express it to 3 decimal places. So our final answer here for the last question will be 0.558. And that is your homework completed.